Okay, cool. Good morning, everyone. My name is Alban, and today I'm going to talk about a project I've been working on for a while now, which is called TrustKit. And before I get into that, something I read on the website for Art into Science is that as a field, we need practitioners to offer implementable ideas and/or reference implementation to reduce the amount of work that someone has to do to implement what they learn. So when I read that, it really resonated with me because that's exactly what we've been trying to do with TrustKit. And that's what I'm going to talk about today. It's more engineering focused than operations, but it has to do with operation as well, as you'll see when we get close to the end. So what is TrustKit? It's an open source library to make it easy to implement a security feature called SSL pinning in mobile apps. SSL pinning and SSL reporting. We released that more than a year ago on iOS, so you can use that in your iOS app. And we also released it last week on Android. So it's still a lot going on. It's all on GitHub, it's open source. And as I've said before, really the goal when we started working on this was to make it as easy as possible for developers to implement SSL pinning. And I'll explain what it is and why you would want that in your app. But that's kind of what I'm going to talk about. As I said, I'll quickly explain what SSL pinning is. Then what made us to start working on TrustKit, myself and my coworkers. And then as we were working on it, as we released it, we realized there are lots of challenges you can solve with a reference implementation, like a library, but there also are challenges that you just can't solve yourself. And I'll kind of talk about that in the limitations we run into. And then a quick conclusion. So first of all, real quick, what is SSL pinning? So when you have a mobile app or browser connecting to a website over HTTPS, it's going to have to validate the server's identity. And to do that, it's going to look at the server's certificate chain, which is something like this, as you can see in Chrome. So if your app or a browser is connecting to datatheorem.com, this is the certificate chain you're getting. So when your app connects, that's what it's receiving. And the way it's making sure that this really is datatheorem.com, which is the company where I work, is by just doing SSL validation, and it's two steps. First, it's making sure that as you're trying to connect to datatheorem.com, the name on the certificate does say datatheorem.com, so it's the right certificate. That's the first step. The second step is to make sure that, okay, this really is the certificate for datatheorem.com, but you need to make sure there's a proof that it's the real certificate, meaning it was signed by someone you trust. Which is going to be a CA. In this case, it's global sign. But there's basically a list of CAs that your browser or your OS trusts. There's about 200 of these usually. Global sign, VeriSign, all these. And so the second step is to make sure that certificate chains up to a CA that you trust. So that's normal SSL validation. That's what browsers are doing, what apps are doing by default. SSL pinning is basically adding one more step, which is not only you want to be sure that someone you trust said that this was datatheorem.com, you also want to be sure that there is one certificate that you know has to be in the certificate chain, for example, this one. You want to make sure that it's actually there. And the reason why you want to do that, I'll get into the details of that, but you don't want your app to accept any certificate chain that that's chains up to a CA that you trust. You want to make sure it's the actual certificate chain that you know you've deployed on your servers. And to do that, that's when you do SSL pinning, which means you're going to make sure that one CA of the chain is there. In that case, for example, it's the intermediate one, which is global sign domain validation CA. And the right way to do this is to basically look at the certificate's public key info, which is one field inside the certificate, which has all the information about the actual key, SSL key, and the algorithm. So in that case, it's an RSA key. You're going to hash that base64 encoded And that's what an SSL pin is. So that's basically the key that's inside that certificate. And when you want to do SSL pinning, that extra step is basically making sure somewhere in that chain there's that key that's there. And once you do that, you're sure that it's the certificate chain you know about and not some other certificate chain issued by another CA that it's not the real one. So that's SSL pinning, in a nutshell. If it's a different chain, the public info will be different, of course. The key will be different. The algorithm might be different. This is an EC key, and so the pin will be different. So that's real quick, what is SSL pinning? And just to kind of recap, so you're adding one more step to validation, which is making sure the chain has one key that you want to be there. So the reason why we started working on TrustKit is because there's a lot of confusion when it comes to what SSL pinning is, where you want it in your app, and how to do it. There's lots of confusion, and that creates a lot of problems, and I'll get into that. When there's a lot of confusion, even within the security teams, that usually leads to developers having to improvise. And in that case, they have to improvise with things like SSL APIs, which are extremely complex. You really don't want to improvise with that. You really want to know exactly what you're doing and how to do it. And the other thing is developers or operation teams not being fully aware of all the side effects that can happen when you do SSL pinning and all the challenges that you're going to run into. So we clearly saw, again, a lack of understanding, even to the security teams I talked to the developers I talked to. There seemed to be a lot of confusion. And the first thing to ask yourself if you're a mobile developer is pinning for your app? And the first confusion I've seen a lot is that sometimes people say that everybody should do SSL pinning. Every app in the App Store should do it. You see that a lot also with bug bounties. If you have a bug bounty for your mobile app, the first thing you're going to get is, oh, you're not doing SSL pinning, you should do it. So the thing is that's absolutely not true. And if you're kind of forcing it on your developers, also you don't really need it, you're going to have way worse problems. So the question you have to ask yourself, honestly, is do you really need it? And the answer to that is you have to really understand why you would want that, right? And the only reason why you would want it, basically, is if you're worried about, as I was showing earlier, that certificate chain, if you're worried about someone being able to force or compromise a CA so that they issue a new certificate for your server that you're not aware of. So if VeriSign issues a certificate for datathreat.com, and we know it's not us, because we're not using VeriSign, and we want to block that in our app. That's mainly the one use case. So as you can tell, I mean, being able to force a CA to do things, it's pretty sophisticated. So it's clearly not, not all apps are going to be potentially vulnerable to that. The other reason would be if your app deals with really personal data, and you don't want employers who are doing, corporate like traffic interception. You feel like they shouldn't be able to see that app's traffic. So let's say it's a mobile banking app. Your users' employers probably should not be able to see the traffic anyway. One big confusion I've seen is people think it prevents reverse engineering of the app's network traffic. So they think that by doing pinning, people are not going to be able to kind of like put the app on their device, take it apart, see which connections they're making to the APIs, and kind of reverse engineer the whole thing. And that's not true. It's kind of a side effect. It'll make it slightly harder, but it's not true. For example, Pokemon Go released an update where they added pinning, and it was clearly to make it harder to reverse engineer the app. And for them, it made sense because they were trying to prevent people from cheating by directly calling the mobile endpoints instead of using the app. So it kind of made sense, but it's not the goal of pinning. It's just kind of a side effect. So that's the whole thing. Is pinning for your app? Probably no, but the way to think about it is either you have a very, very large user base with some sensitive data, so your Facebook, Google, companies like that, so it's kind of clear that you do need that. or you have a smaller user base, but you have extremely sensitive data, so a bank or something like that. And that's pretty much it. So when you hear people saying, oh yeah, you should totally do SSL pinning, that you have to make sure you ask yourself these questions first. Otherwise, you're going to run into a lot of problems. And I'm going to talk about these now. So let's say you're building an app, and now, okay, you've decided, yes, we need SSL pinning, let's do it. Plenty of challenges ahead. The first one is code level, what I call code level challenges, which is actually writing the code to do it. It's pretty challenging. And that's something we wanted to solve with TrustKit. The reason why is now you're going to have to deal with SSL and certificate APIs, so you're going to have to get the certificate chain, look at the certificate, make sure the key is the right one, all these things. It's kind of a minefield. It's well known that that's where you're going to make a lot of mistakes, unless you really, really know what you're doing and you're really used to dealing with these things. And when you make a mistake by customizing SSL validation, you really have a really bad security issue after that. And I'll give some examples. So I worked on the iOS version and the Android version of TrustKit, so we had to deal with these things. And I'll give two quick examples. So on iOS, there are no APIs to extract the public key info from a certificate. So that field I showed you that you have to hash, there's no way to get it on iOS until iOS 10. So we had to be very creative and still secure, but that's one challenge that your developers are going to face if they try to do it themselves. On Android, it's notoriously really hard to customize SSL. It works with a bunch of callbacks. It's really hard to know the order in which they're going to get called. Some of the callbacks don't give you all the parameters you need to make the validation. They don't tell you the host name you're trying to connect to, so there's a lot of problems here. I'm not picking on Android because it mainly has to do with how Java was doing it. So it's more like the legacy from Java, and it's also fixed on Android. But if your app needs to support older versions of Android, you're going to have to deal with all that, and it's really complex. And as I said, that's something we were able to kind of solve with TrustKit. So that's on iOS when you want to use TrustKit. Really, all you have to do now, and I'm pretty happy with the result, is you just initialize it with some kind of pinning policy. So that's for datatheorem.com. There's a bunch of settings. And then you provide your hashes, the hashes you want to see in the chain. And you just initialize it, and then you're done. So you don't have to deal with any of the APIs. You don't have to go into your app's code and find every single location where you're making connection and change that. You just have to do this thing once at the beginning, and then you're done. So it shows that we worked really hard on solving these challenges when we could, and in that case, it worked out really well. And it's much, much easier to do it than doing it yourself. And you don't have to trust me on that. If you don't trust me, you can just look at the code on GitHub, and you'll see that it's actually pretty complex. So that was the first kind of challenges if you want to do pinning. And that one, we were able to solve it with TrustKit, but there are other challenges that a reference implementation or library can't really solve for you. And there's a really good example of operational challenges you're going to face if you're doing pinning. And that's a news article. There's not a lot of information, but that's one news article I found from a month ago. Users of Barclays Bank mobile application have been left without the possibility to pay for purchases due to a legacy intermediate SSL certificate. So if you read the article, it says, I love how it starts. On a Thanksgiving Day, November 24th, 2016, an emergency has occurred. So it's pretty good already. Customers of Barclays Bank, which were users of mobile banking application, were unable to perform any transactions due to pinning the outdated intermediate certificate in the application. So I'll explain what happened. But clearly there were like a huge emergency because of how the Barclays app was doing pinning. And it's very interesting. So what happened was, some time ago, the mobile app team decided to do pinning in their app. From what I've found, I'm not 100% sure, but it seems like that app was the one to receive payments from your customers. So it's like Square, but from Barclays. So it's not your personal banking app. It's the app you use when you have a store and you want to receive payments from your customers, which is a much bigger deal in a sense. So it's the app to receive payments. They decided to do pinning in it by pinning one intermediate certificate. So that's the certificate chain. They decided to pin this one, which means that now, once you do that, the app will only accept to connect if there's that one specific certificate that's inside the chain. So they decided to pin that, and then sometime later, in November, it's more like November, not December, they renewed the server certificate for the mobile API, which is on payliquid.com. But the thing is, they use the same CA, same everything, but the CA issued it with a different intermediate certificate because they had moved to a new system to issue certificates. And so it happened that the one in the middle, that one has changed because that one, the one you're looking at now is actually the new one, but before it was an old one from a different system. But that thing changed. And Barclays hadn't done anything wrong in that case. It's just the CA happened to have changed their chain. And once that happened, pinning validation would fail within the app because, again, that one changed, and that's exactly the one the banking app was looking for. So once it changes, the app will just not be able to connect to the servers, and it will completely stop working. So if you keep on reading the article, several thousands of customers of small and medium-sized businesses operating mostly in the UK market will not be able to perform any transaction from 8:30 a.m. on the Black Friday and during the holiday shopping period. This will affect hundreds of thousands of customers' transactions until the application is updated and then released again. That usually takes about a week at best. So again, sometimes you kind of hear that, oh, everybody should be doing a self-pinning. If you're not doing it, just spend that week writing the code, and then you should be good to go. That's, I mean, completely false, right? Completely wrong. That's a very good example. So the scenario that's described here did not actually happen in the sense that they were able to work around it in a very interesting way, actually. So to avoid like that, having to shut down on a Black Friday, what they did instead is they asked their CA to reissue a new certificate with the old system and the old CA, so the app would still work. The really funny thing about that, though, is to do that, the CA had to break the rules because they were supposed to move away from the old system. So the CA broke the rules with the CA baseline requirements, which is how browsers enforce rules on CA so they don't do anything they want. And so the CA, which is basically semantic, broke the rules, and now they're in trouble with the Chrome team and Mozilla and everything. So from just this simple idea, which is pinning, you get to pretty, pretty crazy consequences, I think. So these kind of challenges, you may have the best reference implementation in the world. There's no way you can help with that. It's really up to the team to do it correctly. And again, confusion, misinformation doesn't help at all with that. One thing Barclays, I don't have the details, but it seems like something they didn't do that they should have done, was that whenever you do pinning, so you're going to pin that one certificate in the chain, you also need to have a backup pin that you put in the app. And it's a different certificate chain that you have somewhere, like with the keys in a safe, and you're ready to deploy it if disaster strikes and that current chain doesn't work for some reason. You have a backup certificate chain with a backup pin already in your app, so you can rotate easily. Seems like they didn't do that, or I don't know. But yeah, so there are ways, to tackle these challenges, but you have to be really aware of them, and you have to know what you're doing. You can't just rush it. And it's, of course, more burden on the ops and the dev teams. And again, I don't see a lot, it's better now, but I don't see a lot of security teams thinking about these things, which are crucial, right? If your app completely stops working to all of your users, security doesn't really matter at this point. And that's also how you get your developer team to hate security. So you have to be very careful with these things. The last thing I'll talk about is, let's say you did it, you wrote the code, it's working perfectly, you have all the processes in place, everything is good. You will still have side effects with something like pinning. It's still going to affect your user base. So even if you do everything correctly, one thing that will happen, and that's kind of the point, is your app will stop working for some of your users because maybe there's some networking device that's trying to intercept the traffic, or there's something else going on. And it's kind of scary, I think, when you're building an app to just roll out pinning and you don't even know who's going to be affected, really. So for that part, we were able to kind of help with TrustKit because we put a feature called SSL reporting in it, which is basically, once you use TrustKit, whenever there's some kind of SSL failure in the app and the app is not able to communicate to the servers, there's a report that's sent with some information about what happened. That's actually useful to all apps. So I don't think all the apps on the store should do pinning, but SSL reporting is useful to all of them because it tells you what's going on with your users around the world and why is the app failing. So it gives you really an overview of how many users are facing issues, and also if you were to enable pinning and enforce it, what would happen. And then you can make a decision based on these numbers, whether it's reasonable to enable pinning or it's not. That's what a report looks like. I removed the certificates, but the main thing is the certificate chain. So it's the certificate chain that was received that didn't match the one that was expected. I removed there should be more, the actual certificate in here, but I removed it so it's small. And then there's some other information, the host name, the pins that were expected that weren't found. And so that's what you kind of receive, and so you can send it to some server that you control. One thing we have as well, and I'll do a quick demo, is we have our own reporting server, and some apps have decided to send the reports to us. It's not really a demo, but I'm going to show you some of the data we've received. So it's kind of our internal UI for the server that receives all these reports from all the users. That's a banking app. I changed the names, but it's a banking app in North America. And so that's the kind of information you get. So something we've built is we have a component that tries to triage all these reports based on what we think happened by just looking at the certificate chain and all sorts of things. And we're still like kind of crunching the data and coming up with stats and everything, so we haven't really done that yet, but we have a lot of rules now. So as you can see, so total reports is 30,000, which is not a lot. And it's mainly caused by captive portals, meaning when you're at the airport and it's trying to redirect all your connections to the portal where you're supposed to log in to get the internet. So that also affects apps, and you can see it there. So when that happens, the app isn't able to connect because you don't have the internet yet, which is not a bad thing. The connection failed anyway, but it's interesting to see how many problems it's causing. There's corporate appliances, so that's mainly your employer looking at what you're doing. And then people using Charles Proxy are trying to reverse engineer your app. Devices that have where the time is wrong. So if the time is wrong on your phone, you're probably not going to be able to connect to anything. And all sorts of other things. There's another one that's like a music app. In this case, we have a lot more reports, almost 200,000. And you see all sorts of things as well. But the key thing here is that with these numbers, you're really able to make a decision. Okay, do we want to cut off all these users, or do we have to think a bit more about it? And it also depends on what your app is doing. It's not the same if it's a banking app or a music app. I think I still have some time, so I can talk about one of these things. One thing we've seen that category, device tracking, was pretty interesting. So there's a few apps on the store. That, by the way, that's iOS only. That's iOS only. And we've seen some apps on the store mainly for blocking ads that, and it's the last thing I'll talk about. We've seen apps on the store, when you install them, they set up a VPN on your phone and a custom CA, and then they start doing a manual on all your phone's traffic to block ads, and that kind of showed up as well in our reports because the pinning validation fails because there's something that's trying to look at what you're doing. That's SSL reporting. And that's pretty much it. So the conclusion is we found a kind of a problem, and we tried really hard to make it as easy as possible for developers to kind of approach that problem and solve it. It was very, very well received by the developer community. Now it's used by a lot of apps, such as PayPal, iOS. But the interesting thing, I think, is, and maybe it's obvious, but it wasn't to me, there's lots of challenges that you can solve by just providing a reference implementation, and sometimes they may be more challenging than the code itself. If there's a lot of confusion about the concept, the reference implementation is not going to help. So there's also education, operational challenges as we saw. And the thing that I realized when we released TrustKit was that when you provide a really easy-to-use reference implementation, it actually makes these problems worse because I've seen apps that really shouldn't be pinning. I could tell from the questions the developers asked me that they were not ready, they didn't know, they hadn't thought about everything. But because with 5 lines of code you can do it, they kind of did it. And so I'm not sure what the answer is here, but I still think it's better that they use the good implementation than having them trying to do it themselves. And that's all. So thanks, everyone. Thanks. If you have any questions, or I don't know if we have time.
Okay. Quick question. What's the most common and easiest way that people bypass cert pinning?
So it depends. So that's a good question. The question is, what's the most common way people bypass pinning? There's 2 different things here when you say bypass. There's people who are on their device using their app and they want to see the app's network traffic. So that's a bypass, but it's pretty easy to do. You just have to do, use some tools, root your device, and then you'll be able to see the traffic and bypass pinning. But as I said earlier, pinning is not really meant to prevent reverse engineering, so it's a bypass, but it's fine. Like it's not a problem. The other, what I would call the real bypass, is when you have a network attacker who's able to create a certificate chain that chains up to a valid CA, and it's not the one you're expecting. That's like the real attack that pinning is trying to prevent. It's usually high-profile attacks, and we've seen a few of these when a while ago when I think Komodo was hacked, and then they issued certificate chains for gmail.com and a bunch of other services, and it was used to man-in-the-middle users in Iran, I think. I might be mixing 2 stories, but that happened. So it's usually high-profile attacks. And
the case you were talking about was actually the reason for it, because they weren't using it.
Yep. Yeah, and so it was detected by Chrome, the Chrome team, because they are doing pinning on the Google domains, and they started seeing that random chain that was valid, but not the real one. Yes.
So just you were talking about doing SSL reporting.
Yeah.
I take it from what you were saying there that TrustKit has a way to configure it to sort of fail open, so you can collect that data before you actually deploy your PIN.
Absolutely. Yeah, that's how it's meant to be used. So you set up your pinning policy, but you tell TrustKit to not enforce it. So you're going to see these reports, but the connection is still going to work. Yeah, that's the whole point. Yeah.
Assuming that everybody starts pinning, do you think the browser and the OSs are going to scale with the number issue?
So two things here. So pinning in mobile apps is much easier than pinning in browsers, because in mobile app, you can kind of update the app and change the pin policy. Right now, you can do pinning in browsers. There's this new feature called HTTP public key pinning, so you can do it in the browser. I would not advise anyone to do it, because in the browser, if you make a mistake, like Barclay did, you have no way to resolve it. People are not going to be able to connect to your website until your pinning policy expires. So you don't have that kind of out-of-band thing where you can just update your app and change the pinning policy. In the browser, it's really, really dangerous. So are browsers going to scale? I don't think so, but I don't think they should, because again, pinning is not for every website and every app. So I think we have to accept the fact that pinning is not for everyone, and it's pretty sophisticated, right? Thank you very much. All right, thanks.